Alright, welcome back. So today we are going to be looking at our first set of stoichiometry, and that is something called gravimetric stoichiometry. It's just a little reminder what stoichiometry is. This is just a method for predicting the quantity, so how much, of a reactant or product that we have in a chemical reaction. So with gravimetric stoichiometry, what this means, it's stoichiometric analysis involving specifically just masses of substances. So our first one right here, we're just going to be dealing mostly with mass. So of course we do have our equation. We know that mass is equal to number of moles times molar mass. So you can imagine that molar mass will be showing up as well as masses. So this is the first equation we're just going to be dealing with. It's one that we've dealt with a bunch of times already. And then of course, as we kind of go through all these stoichiometries, there's going to be a mixture of stuff. So just so we know that, we'll kind of keep a running tally of all the equations we're using as well. So all stoichiometry problems are going to have the exact same process. So you'll notice we're going to go over the same process every single time, but what's going to change is going to be step 2 and step 4. So it's all a 4-step process. Now the first process we're going to do is write the complete balanced chemical equation. And of course, we can calculate the molar masses for our appropriate substances, and that is the substance that we are given. So in all these stoichiometry problems, we're going to have to be given at least a mass of one thing. So we're going to classify that as our given substance, and then of course there's the mass of our wanted substance. And that's what we have right here in the note. So the given is the substance we are given information about. Our wanted or required is the substance we're asked or we want or required to solve or find information about. Now, our step 2, after we write out our balanced chemical equation and find the molar masses of our wanted and our given, our step 2 is going to be find the number of moles of our given substance using our molar mass equation. And that is number of moles is equal to mass divided by our molar mass. So step 2 will always be the same. Now, this equation could change depending on what we are given, but just for our gravimetric stoichiometry problems, second step is always going to be using this equation right here. Our third step, this is a new step for us, so we're going to determine the number of moles of our required or our wanted. I'm going to use the terms wanted. We're going to determine the number of moles for our wanted substance using the mole ratio from our balanced chemical equation. Now, our mole ratio is number of moles of our wanted over number of moles of our given. And of course, our number of moles given is from step 2. Now, what we are going to do, or our equation, is number of moles for our wanted is equal to number of moles for our given times our mole ratio. So our mole ratio, this is basically a conversion factor that we've used before. But now we're just going to simplify it a little bit. So the mole ratio is the ratio between the molar amounts of any two elements, ions, compounds, or whatever. And of course, we use the mole ratio is identical to the coefficient in that equation, which we have used before. So in all stoichiometry calculations, the third step is going to be the same, and the mole ratio is used with the coefficients of our wanted substance in the numerator and the coefficient of our given substance in our denominator. So what that means is mole ratio is equal to the coefficient of our wanted over the coefficient of our given substance. And the coefficient, these are going to be the molar coefficients from our balanced chemical equation. Then of course, after we've done step 3, when we finally have the number of moles of our wanted substance, step 4 is we're going to solve the question, usually solve for mass, using the molar mass and basically this equation right here. So mass is number of moles times molar mass. So of course, for all of these calculations, do not round until your final answer. Try to keep as many decimal points as possible. So I'm going to go over examples 1 and 2 with you, and hopefully you'll be able to get example 3 on your own once we get going. So example 1, let's have a look at this. So it states, when oxygen and air reacts with iron, rust, iron 3 oxide is formed. What mass of oxygen is used for every 100 grams of rust formed? So our first thing, of course, is the reaction. It's the formation of rust. So what that means is our step 1 is our balanced equation. So in this case right here, our balanced chemical equation is we have iron plus oxygen because it's a formation reaction, and we're producing iron 3 oxide. So iron 3 oxide, remember, it's iron 3 plus, oxygen is 2 minus, so when we do our drop and swap, the 3 is going to go in front of oxygen, the 2 is going to go in front of iron, so we got Fe2O3. And of course, rust we know is solid. So this is our on-balance half reaction. Now in order to balance it, of course, we look right here, oxygen kind of screams at me a little bit right here because we have 2 and 3. Obviously, we need to find a lowest common multiple between those, which is going to be 6. So that means we have to multiply rust by 2, multiply oxygen by 3, and then in order to balance out the irons, we have to have that one in 4. So now we have our balanced chemical equation. Now also, what is kind of handy to do is, as soon as you get this step done, highlight your wanted and your given. So what I mean by that is, this question states that when oxygen and air reacts with iron, rust, iron reacts with foreign. So what mass of oxygen, all right, is used? So this one is, so that means oxygen is our wanted substance. And for every 100 grams of rust form, this is our given substance right here. So that is how you kind of read the question and figure out what is your wanted and your given. Now also, as it said up above, you can write out their molar masses or have them off on the side if you want to, which is always handy. So I'm going to do that as well and just kind of have that above them. So oxygen, remember, we don't worry about the coefficient, it's just oxygen is O2. So that means the molar mass is 2 oxygen molecules, and of course when you look at your periodic table, oxygen is right here with a molar mass of 16. So 2 of them together gives us a total molar mass of, if we want to, molar mass equal to 32.00 grams per mole. And then same thing, if you just want to do iron, this is just so we know we're going to have to use these in our calculations later, and which you can get the molar mass of iron really quick as well, just by adding up 2 irons and 3 oxygens, and you should get 159.70 grams per mole. So that is step 1 complete, where we have our balanced chemical equation, we highlighted our wanted and our given substance, and we also figure out the molar mass of both. So now we are ready to move on to step 2. Find the number of moles of our given substance. So because we're just dealing with masses, we know number of moles of our given is, so I'm just going to shorthand it Ng. So our given we have right here is iron. So this is just mass over our molar mass. So the mass from the question was 100 grams. The molar mass for rust, we just calculate. And we get a number of moles of 0.6262741 moles. And that is step 2 completed. Oh, sorry, that's not 6262, it's 6261. Sorry, just read that wrong in my calculator. Either way, we can move on to step 3. Find the number of moles of our wanted using the mole ratio. So for this one right here, we can look or turn the previous page and look at the equation where it said number of moles of the wanted is equal to number of moles of our given times our mole ratio. So, and remember the mole ratio, this is just as I've written it up above there, the mole ratio is the coefficient of the wanted over the coefficient of the given from our balanced chemical equation. So when we complete this, number of moles are given, we just calculated, so 0.6261741 moles, and we're going to multiply by our ratio. Now our ratio is going to come from our balanced chemical equation. So same thing, this is why we highlighted our wanted substance was oxygen, and the coefficient in front of oxygen is 3. So therefore in the numerator we have 3. And our given substance was rust, and we can see the coefficient in front of that is 2. So that goes in the denominator. And then we get an answer of 0.939261 moles. Sorry, just kind of ran into a little tight there. That's fine. And finally, last but not least, it's our step 4. Solve for mass. Because that's what the question's asking. It said what mass of oxygen is used. So we know mass is equal to number of moles times molar mass. So we use our number of moles that we just calculated in equation 3 there, because that is our wanted substance. So that's our 0.939261 moles of oxygen times the molar mass of oxygen, which we calculated up here, 32.00 grams per mole. And we are left with 30.1 grams. And of course, that is 3 significant digits, because from our question, it was at 1, 2, 3 in that 100 grams. That was our 3 significant digits. So we can have that right here. And that is how we use our 4 steps for stoichiometry to solve all of our questions. Now, every question that we get is basically going to come down to these 4 steps. Now, even when we get into different types of stoichiometry as well, solution and gas, it'll be the same thing. The only thing that's going to change is the equation we use for step 2 and the equation we use for step 4. Other than that, balanced chemical equation and using the mole ratio will always be the same. So like I said, I'm going to do example 2, kind of explaining it as we go through and all that steps. And once again, step 3, you guys should probably pause the video, try on your own to kind of get it. So let's look at our next one, example 2. All right, so for example 2, it says a solution of copper 2 sulfate is poured into a beaker containing 15 grams of elemental silver. What mass of copper will be produced? So first step, balanced chemical equation. So we're going to do the exact same thing, where we go step 1, balanced equation, and we can write out our balanced chemical equation. So for this one right here, we can see copper 2 sulfate is poured into a beaker containing 50 grams or 15 grams of elemental silver. So we have a solution of copper 2 sulfate, so that's CuSO4, and it is aqueous. Now the reason I got that chemical formula, if we wanted to kind of do this up above, copper 2 is that, sulfate is this, we do our drop in salt, we just get CuSO4. And because it's a solution, we write AQ. Now this is added to elemental silver, so that's just silver, Ag, and because it is an element, it is a solid. Now you'll notice this is a single replacement reaction where you have an ionic compound and an element. So that means silver is going to replace copper, and copper is going to be our new element. So copper is an element, is Cu solid, and then our new ionic compound is going to be silver sulfate. So remember to do drop and swap, because silver as an ion is only +1, sulfate is SO4 2-. So that means the 2 is going to drop and swap in front of silver. So you got Ag2SO4. Now, for the state of matter of silver sulfate, we don't know. So that's where you are going to have to go back and check the solubility chart, right? Because we have sulfate right here. Now, most things are soluble, but we'll notice that silver is down here in the slightly soluble, so it needs to be a solid. So we're going to go back and write solid, just like that. And now we need to balance our equation. So in order to balance, all we need to do is stick a 2 in front of our silver, and that should be it. All right. Now, before I go through, I'm going to highlight my given and my wanted, and then also get the molar masses of my given and my wanted because I know I'm going to have to use them. So reading the question, it is saying that we have copper 2 sulfate is poured into a beaker containing, in this case, 15 grams of our silver. So that means our silver is our given. And it's saying what mass of copper will be produced. Copper is our wanted. And just really quick, you can go and get the molar masses for these here. These are just, well, as they are. So remember, when you're getting the molar mass, never use the coefficient in front. So the molar mass for silver is just, well, the molar mass of one silver atom, which is the number given directly on the periodic table. So we have molar mass is equal to 107.87 grams per mole. And the molar mass for copper, same thing, just directly from the periodic table. Molar mass is equal to 63.55 grams per mole. And of course, we know we're going to have to use these because we're dealing with gravimetric stoichiometry. So our next step, step 2, is we find the number of moles of our given. So where we're only dealing with gravimetric stoichiometry, that means number of moles of the given is equal to mass over molar mass. So our mass is, we have 15.0 grams. The molar mass for silver, which just calculated up here, 107.87 grams per mole. And we have the number of moles of 0.13906 moles. Our next step, 3. So we find the number of moles of our wanted using the mole ratio. So, of course, from our equation on the previous page, we number of moles of our wanted is equal to number of moles of our given times the mole ratio. So we use our number we just calculated. And remember, the mole ratio is the coefficient of our wanted over our given. So when we go up and look at our balance equation, the coefficient of our wanted, the number in front of copper, is 1. The coefficient of our given is 2. So when we do this, we get a number of 0.069528 moles. Then finally, last but not least, 4. Solve for mass. And of course our last step, because that's what's saying what mass of copper is going to be produced, so we use our equation that was already written in the notes there. So mass is equal to number of moles times our molar mass. We have our number of moles from step 3, 0.069528 moles, times our molar mass we have written above, which is 63.55 grams per mole. And when we multiply two of these together, we get an answer of 4.42 grams. Then, of course, that is 3 significant digits because the only number I'm given up here is 3 significant digits. So that is, once again, following the 4 steps for stoichiometry to solve the question. So, of course, with these here, the big thing is just making sure you get your balanced chemical equation set up first. If you can do that, you're probably going to be fine if you do follow those steps. So it is really handy to kind of have the equations written down so you just know, and of course make sure to follow the steps every single time. So let's have a look at our last question. So this one reads, teacher mixed 47.3 grams of solid sodium phosphate into a solutions. Students added excess of calcium nitrate into solution. So what is the name of the precipitate? So just remember from our last lesson, the precipitate is a solid that forms. And what mass could the student expect to find after the precipitate was filtered? So, of course, this goes back to the introduction we kind of had yesterday, where filtration is kind of a technique where we form something that has a low solubility, we make a solid, and of course, we filter it at the end. So, you definitely want to try this one on your own and try it until you get a mass of the precipitate 44.7 moles with 3 significant digits. So if you're not sure, or if you're working on this and you can't get it, just look at the answer key that's already posted up on Google Classroom to see step by step, so step 1, 2, 3, and 4, and see if you can get it. But I want you to definitely see if you can get this answer first before you look at the answer key. And that is going to be it for our gravimetric stoichiometry. So tomorrow we're going to be looking at, or the next lesson, not necessarily tomorrow, especially if you just watched the video right after this one, we're going to be looking at testing stoichiometric method. So basically, laboratory techniques. How do we test it to make sure we're actually doing good? So we're just going to have a look at that, and then that'll be it for the week. So try this one out. Make sure you follow stuff in the workbook, and see you guys for the next lesson.